Welcome back. The software design, a crucial part of the system's physical viewpoint, is waiting for us. We will show you how to set up the software architecture based on the requirements and the system architecture, and how to define the detailed software design. You will learn how you can easily navigate from a software component to the relevant requirements, to the test spec, and to the hardware component the software runs on. Before we start with the software design, PREEvision provides the possibility to define dedicated requirements for the software. For the collision avoidance, we have a simple requirement stating an algorithm for routing and navigation shall be provided. It's the same requirements editor as for stakeholder and system requirements. We can edit and format text or enter images. And we can link the requirement, for example, with a software component. But let's start with the actual software design. For the modeling of the static aspects of the software, the so-called software architecture, PREEvision provides software architecture diagrams. Based on software requirements or the system design, we define software components and how they are connected. We have a software component that processes the data of the LiDAR sensor. It is providing information for the data acquisition software component. And here is the component for collision avoidance. We want to use the information provided by the terrain awareness component for the calculation of collision avoidance. So let's connect the sender port to the collision avoidance software component. Besides defining the architecture, PREEvision also allows us to define the detailed software design. Here we have a class diagram that describes the inner structure of the collision avoidance software component. We want to expand the interface of the trajectory algorithm. For the input pre-processing, we define some properties: velocity, distance, and heading. For the post-processing, we define a method to serialize the data. The multiple traceability editors show the connections to the rest of the model. We can easily find the requirement the software component is based on. We can also find the logical function of the system architecture that the software component implements. The same is true for the detailed design. And of course, and very importantly, for the linked test specifications. There is one thing we must model. We must define that the collision avoidance should run on the microcontroller of the control unit that is dedicated to navigation and routing. We simply take the microcontroller and drag it to the collision avoidance software component. How simple was that? That's it for the software design for our vacuum cleaner. In part 5, we will cover the other major aspects of a system's physical viewpoint. We examine the design of the hardware architecture more closely. See you then. Would you like to check out model-based systems engineering with PREEvision for yourself? Go for it. We offer the example model from our tutorial in a hosted PREEvision environment. There, you can perform the tutorial steps yourself using PREEvision. If you are interested, please visit preevision.com/trial. Thanks for watching.